As chemists, we usually focus our studies on matter, so let's take a moment to define what matter actually is. Matter is anything that has mass and takes up space, and it can be classified in two different ways. It can be classified by either state or composition. So in your notes, I highly recommend that you spread these two branches of this chart out pretty far because we're going to be filling in a lot more branches underneath each one. So we're going to start with the states of matter. So first of all, what is a state of matter? The state is just the physical form of matter. So matter can take three different forms, at least three main forms that we're going to be studying in this class. And those should be pretty familiar to you. Those are going to be our solids, liquids, and gases. So now we're going to talk about the differences between these. So some of the characteristics of a solid. In a solid, the molecules can vibrate in place, but they don't actually move locations. So they're staying in the same physical location in space, even though they have a little bit of movement in place. And they're usually packed pretty close together. There are two different ways that they can be packed. They can be either a crystalline solid or an amorphous solid, which means that if they are crystalline, they're going to be packed in a very regular, organized, repeating pattern. Just as you see here in this example, which is a diamond. On the other hand, solids could be amorphous, which means that the molecules don't appear in any particular order or pattern. They're just kind of all packed in together. And you can see in this little diagram here the difference between something that's crystalline or polycrystalline, meaning lots of little crystals, or something that is amorphous, so having no particular organization to the atoms or molecules. Liquids differ a little bit from solids in that, just like the solids, they can vibrate in place, but what they can do differently is those liquid atoms and molecules can move locations. So they can actually change from one particular location in space to another location in space, even though they're still relatively close together. Something else that's special about liquids is that they have a definite volume while still taking the shape of their container. So what this means is that, let's say in this Erlenmeyer flask that we have here that's full of some kind of liquid matter, let's say that that is 20 milliliters. Even if we take that liquid out of that Erlenmeyer flask and put it in a flask of a different shape and size, we're still going to have 20 milliliters of liquid. We're not going to change the volume of liquid that we have. What might happen, though, is we might have a different shape of liquid. So let's say that our new container had a round bottom instead of a flat bottom. In that case, our liquid is going to take the shape of that round container, even though we still have the same volume. And then we have the gases. Just like solids and liquids, gas molecules can also vibrate. They vibrate in place. But like only the liquids, gases also move locations, like physical locations in space. The difference here is that gas molecules are usually much, much further apart than liquid molecules are, and they tend to move more quickly than molecules of liquids. Gases have no definite volume, so that is something that is unlike the liquids or the solids. They have no definite volume, which means they can expand or contract to fill the size of the container that they're in. This also means that they can be compressed into a smaller container, or if you put them in a larger container, they will fully expand to take up all of the volume that they are provided. So that's how you classify matter by state, so physical form of matter. We can also classify matter by composition. So what is composition? It is the basic components that something is made out of. So when you're thinking of composition, you want to think, okay, what is this substance actually made of? And when we're organizing matter by composition, the first question we want to ask ourselves is the composition variable? Which, what that means is it changing, or is it the same? Is it made of only one thing? And depending on our answer to that question, we can classify matter by composition as either pure or as a mixture. So if our answer to this question is the composition variable, if our answer is no, it is not variable, it stays the same, then we have a pure liquid. If the composition is variable, so if it can be different, then we have a mixture. So the first thing we're going to do is we're going to look at matter that has a pure composition. So something with a pure composition, it's made up of only one component. Once we figure out that our matter is composed of only one component, we can ask ourselves, can it be separated into simpler substances? And depending on our answer, we'll get either an element or a compound. So if our answer to that question, can it be separated into simpler substances, is no, then we have what is called an element. If we look at that pure substance and say, yes, it can be simplified further, then we have a compound. So let's delve a little bit more deeply into what that means. So an element cannot be broken down further. It is the simplest possible substance while still retaining some, I guess, recognizable identity of the substance that it is. So an example of that would be helium gas. Helium gas is pure. It can't really be broken down any further, aside into, if we try to break it down any further, it would just be broken down into a whole bunch of subatomic particles that don't really help define the identity of what that substance is. And that's different from a compound because a compound is something that is composed of two or more elements in fixed, definite proportions. So what does that mean? Let's take a look at a compound that we're very familiar with, pure water. Water, as we know, is H2O. What that means is that every single molecule of water is made up of two hydrogens and one oxygen. If it doesn't have two hydrogens and two oxygens, two hydrogens and one oxygen, it's not water, it's something else entirely. But because that H2O, it has smaller recognizable components, that means that it's a compound. If we were to break that water into its components, we would break it into two hydrogens and one oxygen, and we would still be able to recognize the hydrogens as hydrogen and the oxygen as oxygen. So that's the difference between an element and a compound. So what if we have not a pure substance, but a mixture? When we have a mixture, we have something where the components are in varying proportions. So we have multiple components mixed together with proportions that can vary. And what we want to ask ourselves here is this mixture uniform? And is it uniform throughout? So is it mixed evenly? And depending on our answer to that, we could further classify it as either heterogeneous or homogeneous. So if our mixture is not uniform, so if our answer is no, the mixture is not uniform, it's very unevenly mixed, then we have a heterogeneous mixture. And we can identify this if the components appear in either clumps or in sections. So an example of that would be wet sand at the beach. So if you take a jar of wet sand and kind of like let it settle out a little bit, the sand part is going to fall to the bottom, and the water is probably going to hang around near the top. It's not evenly mixed. The sand is going to show up in clumps. So that's going to be a heterogeneous mixture. On the other hand, if we have something like tea with sugar, all of those components are mixed very evenly. Another example would be salt water. If we go to the beach, and we go swimming in the water, and we know that there's salt there. We can taste the salt, we can feel it on our skin when it dries, but we know that the salt isn't appearing in clumps. Like, we can't distinguish the individual clumps of salt from pure water. It's all mixed together evenly. And that's how you define a homogeneous mixture.